So Module 5 review, everything we've gone over in Module 5, but double the fun. All right, so for this one, we got 3a minus 12 in parentheses. That's all to the power of 2. So what I'm going to do is I'm going to take that, since it's to the power of 2, and just show that it's being multiplied by itself, right? So it's really 3a minus 12, and then it's just multiplied by itself here, okay? So just, just something like this. And then we're looking for the distribution part on this, right? So that means I'm going to take this 3a here, and I'm going to multiply it by, well, 3a minus 12. And then we got the second term of negative 12, and I'm going to show that here like this. But it also will be multiplied by that 3a minus 12, right? Now I'm showing it like this. You're welcome to just show the distribution this way and maybe even this way, which is essentially FOIL since we're looking at two binomials, but it's up to you. Okay, so for my first distribution, I'm going to start with the 3a there in red. So that'd be 3a times 3a, that'd be 9a to the power of 2. And then we also got 3a times negative 12, which would be negative 36a's. Now I'll distribute my purple negative 12. Negative 12 times 3a's would be negative 36a's. And also negative 12 times negative 12, which is positive 144. Okay? And then finally, the last thing we got here is two like terms that we can combine the a terms. Negative 36a's minus 36a's is negative 72a's. So now I've got 9a to the power of 2 minus 72a's plus 144. And this would be considered fully simplified. Now this one's essentially going to work the same way. And you can try it however you want. I think I'm going to keep it that way. So I'm going to take that 5x. Here's my first term of the first binomial. And I'm just going to multiply it by the second set of parentheses, okay? Because it's the same thing. I got to take this 5x and distribute it into this set of parentheses. But then I'm going to take my second term there in the first binomial, negative 6, and I'll be looking to distribute that into the second set of parentheses as well. Okay, so we get something that looks like this if we're going to show the work this way. And then I'm going to distribute, I'll start with the red, my 5x there. So that's 5x times 6x's. 5 times 6 is 30. X times x is x squared. Now I got 5x's times 5, which would be positive 25x's. And then I'll go to my negative 6 in purple there, looking to distribute it into both terms of the second binomial. So negative 6 times 6x's would be negative 36x's. And then I got the negative 6 times 5, which is negative 30. Okay? So now, once again, we see that there are x terms here that I can combine. You got 25 minus 36. That results in negative 11x's. So then I'll just drop my 30x to the power of 2. And also the negative 30 there. And yeah, these, if you're looking to combine these, don't, because none of these are like terms. So even though, right, this x to the power of 2 term has x's and the green term has x's, they don't have the same number of x's. So that's why these are not like terms. All right, for something like this, we're just looking to distribute directly this 6x to the power of 3, okay? So I got, right there, I see 6 times 7, which is 42. But then you may look at that x to the power of 3 times x to the power of 2. Really, all we're going to do is take those two exponents and just add them together. Okay, so that ends up being x to the power of 3 plus 2 is 5. Now, that next term, you may benefit from seeing that negative 1, but I'm going to distribute the 6x to the power of 3 into that term as well. So I'll use a different color since we're only doing this once. But 6x to the power of 3 times negative 1x, I would start with 6 times negative 1, which is negative 6. And then just like we did in red there, I got the x to the power of 3, and then also the x, which if you need to show that phantom 1 there, then do it. But then it's x to the power of 3 plus 1, which is x to the power of 4. Now I'll look to distribute my 6x to the power of 3 to the 5. This one's not too bad because 6 times 5 is positive 30. And then we'll just keep the x to the power of 3. This right here would be considered fully simplified. So yeah, this one is subtraction of two, looks like trinomials, right? And so what we end up with, let's make this bigger here. Like we saw when we went over this lesson, was it 5.5? is that's a negative 1 that I will now distribute into this trinomial, okay? Now, for those of you that understand the shortcut where you're just changing the signs of all three terms on the inside, that's fine. But for now, I think some of you are going to benefit from showing this distribution and the multiplication until you can get that down, okay? It just takes some experience. So I would have negative 1 groups of 10x to the power of 4. So negative 1 times 10 is, well, negative 10. Keep that x to the power of 4, okay? Then I also got negative 1 times 2x to the power of 2. So once again, negative 1 times 2 would be negative 2. And then keep your x to the power of 2. Then we got negative 1 times negative 19. Don't forget that minus sign carries over with the term 19. So that's negative 19. Negative 1 times negative 19 is positive 19. So we show that as plus, okay? Now let's look at the rest of what we have there. So we have this other trinomial right there. And notice how I'm keeping that negative as a minus sign right there. I'm not adding extra symbols. Just keep it there, okay? If you wanted to show the plus sign, that's fine. But there's no other distribution to perform at this point. So that means we pretty much get to ignore those parentheses. Okay, so most of the time, students would just bring this down without parentheses, which is fine. But now that we have this, all we're doing is looking for like terms to combine, such as my x to the power of 4s, right? Got 3 and negative 10, which comes out as negative 7 x to the power of 4. Then we got our x squared terms, negative 8 of them and negative 2 of them, which results in negative 10 of those. Oh, we got we have the 7 x's there, but that's all the x's we have, x terms. 7 x's positive. And then this 19 finally is just positive 19. We're going to drop that as well. No other constants to combine with that, so this is it. Boom. So when you see addition of polynomials like this one, just get rid of the parentheses right there. And just start adding or combining like terms. And so, yeah, we got this b to the power of 4s, right? I'll start with 5 of them and 4 of them. That would be 9 of them, okay? And then the next term I see is the 8b to the power of 2. So I'm looking for b to the power of 2s. There's a couple sets. 8 plus 2 is positive 10. Then the next term I see is the b's, the 4b's, and also this, that's a negative 1b right there. 4 minus 1 is positive 3b's. And then our constants, negative 3 and positive 8, that would be negative 3 plus 8, which is positive 5. And there you go. And if I by chance missed something, I think we checked them all off. Or if I found that there was any other terms to combine here, then I would, but there's not, so that's good. Let's do this one just because it does tend to cause more problems than I wish it did, especially if you're using a calculator, okay? And part of this is reliance on the calculator. Sometimes it's just we forget what's happening with the exponents, okay? So it just so we understand, a common error for this one is where students get this answer. So a common mistake is where students get the answer of 159. And I'll explain how that happens here in a second. But first, let's write out the full function as we see it, negative 5 x to the power of 2 minus 7x plus 51. And we need to replace all of our x's with that negative 4 up there. I'll do that in red. So it's right, because we're replacing this one also with negative 4, right? So that's this x here. Boom, it becomes negative 4. And then this x also with the 7, negative 7, becomes also negative 4. Okay, and then I just evaluate this. And it's true that if you wanted to just put this into the calculator, that's fine. And so how did I get 159, which is incorrect? Well, I didn't put parentheses around the negative 4. If you don't do that, then the calculator will think that there's only one negative. But there's two, right? By the order of operations. So a couple things on this. Some students say, well, negative 5 times negative 4 is 20, and then 20 to the power of 2 is 400. That's a whole different can of worms right there. Don't do that either. That's out of the order of operations. You have to do negative 4 to the power of 2, which would show as negative 4 times negative 4, which is positive 16, right? Then you got negative 5 times positive 16 minus 7 times 4 plus 51. Now if, and before we finish this off, if you had not used the parentheses there, like I said, the calculator just thinks there's one negative, which makes that 16 negative, and then you get an incorrect answer out of that, okay, which we don't want. We want the correct answer. So let's see what it actually is, and I'll correct that. It's negative 4. So, be careful, you guys. Negative 5 times 6, it's still negative 80 there, I guess. But negative 7 times negative 4 is going to be positive 20 there. Now we'll add 51. And I said I couldn't do this in my head before. I still can't, so I'm still going to use a calculator. Negative 80 plus 28 plus 51. Did I hear 1? Oh. I got negative. Thanks. See, now I'm worried. But yeah, I got negative 1 out of that, and that should do it. If you had gone back here and just put these negative 4 in parentheses, you could have punched that into the calculator directly. You could have skipped all this order of operations stuff, because your calculator knows the order of operations, and then you miss some of this. Remember, I think I've told you guys about this. Like, I forgot the negative right there. It causes small mistakes. It's not like it's a huge mistake, really, but it's small enough that it gave us a really bad answer. And you can skip all that if you'll just type it into the calculator, which I recommend. I like these calculators. All right, for a problem like this one, all we're trying to do is find any like terms that we can combine. So what we need from that is not just a terms, but the exponents have to match as well. So I've got this 1a to the power 6, and I'm showing the phantom 1. But the only other a to the power 6, right? We've got a to the power 5, a to the power 5, but there's this other a to the power 6. So I would be looking to combine this. It's a negative 87 a to the power 6 with my other a to the power of 6's, okay? So for me, I would show that as 1 minus 87, which comes out as negative 86 a to the power 6's. And then I would look to combine those with my other a's, but they're a to the power 5's. And yeah, by combine, I'm just showing the expression. We can't actually combine those. They're not like terms. Okay, so how many a to the power 5's do we have? Well, we got negative 51 of them. And then we got positive 6 of them, right? So I'm just going to do negative 51 plus 6, which comes out as a negative 45. A to the power 5, okay? And I think we talked about this in class, but just in case you don't remember, it's possible to switch these up as long as you keep the signs the same. So the 45 a to the power 5, it has to stay negative. Same with the 86 a to the power 6. It needs to stay negative, okay? So we just show it as minus sign. Either one of these will work. They will both get you full credit. This one's kind of, it's not hard, it's just, it can be a little tricky, okay? So we talked about this before already in class today. Remember, if you ever see an x in a denominator, it doesn't even matter what the exponent is. I mean, unless it was negative, which is, they're not going to do anything that tricky. But like this first expression, I see this x to the power 5 right here. It's not any kind of polynomial. It's just, we would say it's none on this, okay? You know what, I'll highlight that just to make it look pretty. Okay, so this one's none because of that x to the power 5. It doesn't matter what's here with this x to the power 6 or the x to the power 3 or the constant. None of that matters once you see this x to the power 5 in the denominator. But again, the exponent doesn't matter there either, okay? This next one, now be careful, because if this was reciprocated, right, x to the power 5 over 19, it would still be, I guess that'd be a polynomial, 4 terms, okay? It's only if the x is in the denominator, that's it, okay? So this next expression, we got 4x to the power of 2 plus 25. I don't see any x's in denominators. I don't see a negative or decimal or fractional exponent, so this one is a polynomial of some type. And since there's only 2 terms here, it's binomial on this one. So I'll just use some technology if I can do this right. Binomial, boom. There we go, make it colorful. And then the next expression here, 3x to the power 4, that's only one term. One is monomial. So let's move this down there, some technology. There we go. Monomial. Oh, this next one's pretty big. And again, I'm not seeing any exponents that are negatives, fractional exponents or decimal exponents, so we're good. This is some type of polynomial. Remember, there's one term is monomial, 2 is binomial, and then 3 is trinomial. Anything beyond that is just a polynomial. So this one we'll say is a polynomial. There it is. Now let's do this one, good old-fashioned scientific notation on this one. We are multiplying the two scientific notations right here. Now, if you're doing this by hand, and you don't have to, because the calculator will do this for you, you can punch in the parentheses, you can punch in the 10 to the power of whatever. Doesn't matter, you could do that if you'd like to. I'm going to do this by hand just so we can see what is happening, though. And for some reason, I actually feel obligated to. So here we go. I'm just going to multiply the two numbers there together. 8.4 times 2.2. Now, it's going to give me a two-digit number. Well, 4 if you include the decimals, but 8.4 times 2.2. Enter. And that gives me 18.48. And then we do the base 10s, right? 10 to the power of negative 42 times 10 to the power of negative 3, which really just means we're going to take the base 10 and the two exponents, 42 and negative 3, and add them. Why are we adding these? Because we're multiplying the bases there, okay? So that ends up being times 10 to the power of negative 45. Now, this would be fine and dandy if we didn't have a tens place value in the 18 right there, but we do. That means that I need to make this big number smaller into 1.848. And then I would multiply, but, oh yeah, so that since I made that 18.48 smaller into 1.848, I would have to make the exponent bigger by 1, okay? So it's still base 10, but since we essentially moved that decimal over to make that number smaller, the exponent becomes bigger as negative 44. And that's it. Yeah, I do want to make sure this is good on the calculator. Yeah, so just punching that into the calculator straight across, it gave me the same exact answer. Didn't have to move the decimal because the calculator, it did it for me. All right, so this one, it's the same thing, it's just, well, now it's division, right? So I'd start with my 8.3 and divide it by 4.15. And yeah, remember that your fraction line is a division sign, really. So that's all I'm going to put in the calculator, 8.3. You can say divide. You can use the N over D button. It's not going to matter. But divide, oh, that's unexpected. It came out as an even 2 on that. Then you can take your base 10s, 10 to the power of 5 over 10 to the power of 9. And since it's the same bases, you're going to take the exponent from the numerator and subtract the one from the denominator. This will give me times 10 to the power of negative 4. And this one is already in scientific notation. For those of you that want to, you can make that 2.0 if you want, but you'll get full credit if you just put 2 right there. Okay, so I'll rewrite this one as a whole number or decimal. And I think this calculator will do that for you, even though it will have a lot of decimal places. But I'm going to show you how to do it by hand, even though, like I said, the calculator will do it. So the negative 6 exponent for 10, that tells us that we're going to move that decimal to the left 6 place values, okay? So let's hope I gave myself enough space here. Let's see what that should do. So there's 1, 2, 3, 4, 5, and 6. So that's where the decimal will be. Any empty place values become 0. So there's 1, 2, 3, 4, 5. I think some of you have noticed when we start changing these scientific notation numbers where the exponent's negative into its regular standard format, it has one less 0 than this number of exponent right there, right? 5 zeros or 6. Whether you notice that or not, it's still the same answer. 0, I'm going to put that 0 though. So 1, 2, 3, 4, 5. There's a 7. 5, 4, 3, 2. Boom. That's it. That's all we got. So, scientific notation. Again, even a number this big, I think the calculator will take that for you, but let's do this by hand. Now, one thing I'm going to set up right here is I know it's going to be multiplied by 10 to some power, right? In fact, right now, since this number is less than 1, it's a decimal value, I know it's going to be a negative exponent of 10 as well. It's kind of like backwards what we saw in that last problem. Okay, so I see where the decimal is. I know where it should be. It should be between the 5 and 6. Okay, because remember, scientific notation, you can only have one number in the ones place value, none in the tens or beyond that, and it cannot be 0. So it has to go between the 5 and 6 for this example, okay? Now that means I could actually write that decimal down as part of my scientific notation. 5.678 times 10 to the power. All I need from this now is the exponent. So how many times was the decimal moved? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So not only was it moved 11 times, it was moved from standard form into scientific notation to the right, which is another way to remember that that exponent here will be negative. I prefer just to look at any value. If it's a decimal value, I just know it's negative. However you want to do it is fine. Like I said, the calculator should do that. For this one, I think we can do this. So some division on this one. Since it's review, I guess I'll kind of speed it up a little bit. But that first fraction there, I'm going to keep it the same. What I would really like is for the operation not to be division. I'd like it to be multiplication. Just if I do that, I got to reciprocate this fraction, okay? So that means my 18w to the power of 8 is now in the numerator, and then my 21v to the power of 7 is in the denominator. I can fix that 7. I don't know if that helped. Okay, and then I personally would be looking for some cross simplification for this, like the 14 and 21. They're both divisible by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. And then I'd look for the 18 and 27. They're cross simplifiable. They're both divisible by 9. 18 divided by 9 is 2. 27 divided by 9 is 3, rather. There we go. Okay, so even just from the numbers, that'll give me a new fraction right here. So on the numerator, I have 2 times 2, which is 4. And then the denominator, 3 times 3, which is 9. All I got to do is figure out the letters. And so I would focus on my V's, I guess, first. Not that you'd have to. Let's see if we can do this. V to the power of 14 over V to the power of 7. That's going to be V to the power of 14 minus 7 with our exponent rules. That will then be V to the power of 7. Since it's positive, that V to the power of 7 should be in the numerator. For those of you that remember, we talked about this. There's more V's in the numerator, so we should expect the final answer to have V's in the numerator as well, which it does. We'll do the same thing with the W's. So we have a W to the power of 8 in the numerator, and then a W to the power of 10 in the denominator. And you could use cross simplification right here. I think this is a little bit more, hopefully this kind of clarifies that just a little bit at least. But now we got W to the power of 8 minus 10, which is W to the power of negative 2. All that means is that we're going to place that W into the denominator, okay? Because, like we've seen before, there was more W's in the denominator than the numerator. For those of you that prefer to see it as a fraction like this, that's fine too, but let's see if I can get that on there. 1 over W to the power 2. There we go. Okay, so that's why, and notice that while we did the math on this with the exponents, it was a negative 2 exponent. Since we moved that to the denominator, it's now a positive exponent, which is what we want. We don't want any answers to have negative exponents on that. So clean that up a little bit. There we go. So let's see, on this one's straight multiplication, so there's no need to change the operation of multiplication. It's already there. It's not like that last problem. We got to reciprocate that second fraction, okay? So we're just looking to cross simplify at this point. All right? So I'd say, well, the 15 and 5, those are cross simplifiable by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. Okay. And then the 49 and 21, they're both divisible by 7. 49 divided by 7 is 7. 21 divided by 7 is 3. There we go. And now, actually, oh, that's interesting, because the 3's are both divisible by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. So even when we go to multiply these, let's move this over a little bit. Right, we got 1 times 7 there in the numerator, which is 7. And in the denominator now we got 1 times 1, which is 1. Now well, I probably wouldn't show this 1 here. I'm going to keep it there just to kind of remember where that 1 came from. Although for my final answer, I will make it a phantom 1 so we don't have to look at that garbage, okay? But then it's the same idea with your letters. So I'll start with the B's on this. We got B to the power of 2 in the numerator, all over B to the power of 6 in the denominator. Now, before we simplify this, since I can see there's more b's in the denominator, I should expect a b value or b variable in the denominator, in the end. Let's look at this, how this works out. Okay, so that's b to the power, with exponent rules, that's 2 minus 6, which would make b to the power of negative 4. Well, that negative exponent is what tells us that that b variable should be in the denominator. Now, I don't really need the 1 in the numerator, but I will show the b to the power of 4 in the denominator, okay? So that's the b's. Now we got the a's as well. So I'll do this in one in green. So I got in the numerator a to the power of 9, all over a to the power of 7. And once again, there's more a's in the numerator than the denominator. So in the end, I should expect the a's in the numerator. You can put that in now, you can put it in later, it doesn't matter. We just need to fill in the exponent, that's all. So that'd be a to the power of 9 minus 7, which is a to the power of 2. Since it's already positive, we'll just leave it there in the numerator. And now I will make that 1 in orange there, phantom 1. Kind of cleaning this up, but there we go. That's our simplified expression. Now, just so you understand, the calculator would have done this simplification for us, right? I'm doing this by hand just so we can see what's happening. But without any of the variables, you could have typed in 15 over 21 times 49 over 5. And when you push enter, it simplifies that into 7 on the calculator right here, which is why, again, that's in the numerator, okay? All right, for problems like this one, I prefer to work on the inside of the parentheses first, just to see what we can simplify, okay? Now, even with that, I'm going to ignore that exponent of 2. I'm just going to work on the inside, okay? And I'd say, look at my x terms. I got x to the power of negative 14 in the numerator. And then the negative 20, so that's minus negative 20 right there. That'll give me a new base x on this case. So that's going to now be x to the power of negative 14 minus negative 20 is positive 6 on that one. And then we got the y terms as well, right? Y to the power of negative 23, but now it's minus negative 44. So that would be then y to the power of 21, it looks like. Now I will look at this negative 2 exponent now on the outside, okay? So that's a distribution of exponents, right? So that's first we got x's, and that'd be 6 times negative 2, which is negative 12. So x to the power of negative 12, and then y to the power of 21, but 21 times negative 2, which is negative 42. Now, like it said in the beginning of the problem here, we only want to use positive exponents. So you could show this as kind of an over 1 situation, where all we're going to do is kind of flip that fraction right there for both the x's and y's. So, yeah, now it becomes a 1 over x to the power of now positive 12, and then y to the power of positive 42. Now, I think we explained this a couple different ways in class. We said if it crosses this line, you change the sign. If that works for you, that's fine. Or you could say negative exponents reciprocate. So you have to separate them separately, by the way. So it's like we reciprocated the x to make it x to the power of 12, and then reciprocated the y to make it y to the power of 42. Just don't forget to put your 1 in the numerator. It's not so common of an error, but it does happen from time to time. And it's not that you don't know the rules, you just forgot to put that phantom 1 right there. You have to show it. I like this one. I like any problem that has a power of 0. Just be careful, though, because sometimes you see that power of 0 and say, hey, look at this, it's 1. No, it's not all 1, you guys. It's just the b variable, because the negative 95 has an exponent of 1. Same with the a. So those do not have powers of 0. I'm going to make the b to the power of 0 1. In fact, not only am I going to make it 1, I'm going to make it a phantom 1, so I don't have to look at that garbage anymore. And in fact, that's it. That's all we got to do right there. That's completely simplified right there. All right, for this one, since it does only want positive exponents, we're going to keep the fraction on this one, but we're just going to flip these. So the t to the power of negative 19, I'm going to put into the denominator, which changes the sign of the exponent now to positive. And same with my base v. Now it's in the numerator, but the exponent becomes positive. That's all. Don't subtract these exponents because they're not the same base. keep them separated like this, and that's good enough. Questions. So on this one, I would personally look to do the 45 divided by 25 first. And like I said, the calculator will simplify that for you. If some of you guys notice that they're both divisible by 5, and that's fine too. It's just 9/5. So right off the bat, I know I'm going to end up with the fraction, 9 in the numerator, 5 in the denominator. And notice I'm giving myself some space because I'm doing this by hand to the right. And then we'll figure out where the A's and B's go on this. So I'll start with the A's, and this is division of those bases. So a to the power of 9 over a to the power of 6 is a to the power of 9 minus 6. And like we've seen before, there's more a's in the numerator here, so I should expect the a's to be in the numerator, a to the power of 3. So it's already positive, so that should also tell us that it goes in the numerator. On the other hand, though, we got the b's. So b to the power of 14 all over b to the power of 6. So that'd be b to the power of 14 minus 6. Again, there's more b's in the numerator, so I'll expect it in the numerator, so you could put it in there now if you'd like. 14 minus 6 is 8. b to the power of 8 in the numerator. And so even though the 5 is not centered, and I'm doing this by hand, so it may not look so pretty, but it works. All right. So a common error on this one is where we get 3 to the power of, let's see, 52, x to the power of 52. No, that's no good, no good. And what happens there is that students tend to think, again, it's just a small mistake, but this 13 exponent is not with the 3. It's a phantom 1 exponent with the 3 right there. So when we look to multiply the exponents, right, this 4 times 13, that is going to be x to the power of 52. That's 13 times 4. But then you got your base 3 to the power of 1 times 4, which is 4 right there. Okay, so 3 to the power of 4 is 81. That's what we want. We don't want 3 to the power of 4, by the way. It is how we get to the answer, but don't put this as your final answer because it's not considered fully simplified. And that's it. There we go. So now, and just like we saw in 5.6 there, this is two monomials being multiplied. And so all we're going to do is we're going to take the numbers and multiply them. 8 times 6, which is 48. And then also the b's, right? Oh, I guess I'll start with the a's. a to the power of 6 times, there's no other a's? Oh, that was tricky. Okay, well, I should have looked at this problem before, but there's no a's or b's or x, y's in either one. Looks like we just end up with everything else just kind of tacked onto that. a to the power of 6, b to the power of 8, c to the power of 10, x to the power of 3, y to the power of 11. Again, the order doesn't matter here. I almost feel like I want to change that to an a and a b right there. I don't know. Theoretically, this is what it looks like our answer is. Let's redo this, though. So I'm going to, there we go. Not so pretty, but it works. Okay, but again, we're going to do 8 times 6, which we already know from that last problem is 48. Okay, but now I do have some a's to combine on this one. I got a to the power of 6. And also a to the power of 3. So that'd be like a to the power of 6 plus 3, which is a to the power of 9. That's a 9. That's better. Then we got some b's on that, right? So b to the power of 8 times b to the power of 11. So that'd be b to the power of 8 plus 11, some old exponent rules. So b to the power of 19. So b to the power of 19 here. And then the c to the power of 10, there's no other c bases, so that just stays there. And this would be a simplified format there.